Thanks everyone for joining the session. So today we are going to discuss about ping. What do you mean by ping? Ping is a command. It's a troubleshooting command for networking domain. Okay. See here, ping. I want to check the reachability of Google. So ping www.google.com. So if you have reachability, then only you will access the Google website. See, you can see, right? So it's a domain name. We remember the domain names, but it is each domain name means it's a Google server. Each domain will have a server. Server is a layer 3 device. That server will have a IP address. So what it is doing, it is checking the reachability with the server. So server IP address. Now let's ping and the IP address. Look at this. So which reachability you are checking? Layer 3 reachability. Look at this here. I given a ping command and with the IP address. This is called destination IP address. This server or computer or CC camera from your local machine, you want to check the reachability, right? So ultimately, when you join as a network engineer, regularly every day you will use this command so that if the reachability is good, your network is good. Otherwise, you need to troubleshoot it. Okay. So the thing is, once you initiate a ping, what is happening here? Front end. Let's discuss about front end. So what is happening? It is sending some packets, right? You see, right? How many packets it is sent? It is sent 4 packets. Yes or no? One, two, three, four. How many packets your computer has sent? 4 packets. Are you listening to me, everyone?
Yes, sir.
So,
Yes, sir.
so it sent 4 packets here. Okay. Now, how many you received? 4 you received. It means, see, I have sent 4 packets. I have received 4 packets. It means there is no packet loss. So you have a reachability with 0% packet loss. So ping will check the layer 3 reachability. Okay, ping is a layer 3 command. It will check the layer 3 reachability and you will come to know is there any packet losses. If you see any packet losses, right, there is some network issue, some connectivity issue between from your source to destination. From your source to destination, there is a lot of devices, right? Look at this. This is my computer. This is a Google server. It is located in Texas or somewhere else in this world. From here to the Google server, there is a lot of routers. So in case if any packet losses you see, right, you have to troubleshoot it. Where exactly is the issue? Going forward, you will learn. Okay. So ping will check the layer 3 reachability and it will tell you is there any packet loss, and also it will tell you the round trip time. What is that? Round trip time. It means suppose you if you want to travel from Hyderabad to Bengaluru, so Hyderabad to Bangalore, Bangalore to Hyderabad, so return journey, so total journey is called round trip time. How much it will take from Hyderabad to Bangalore? Via bus or car, it will take minimum 8 9 hours. So up and down it will be 18 hours, right? That is called round trip time. Here also the packet is leaving from your computer and it is receiving from server to your computer. Total how much time it is taking? Milliseconds, 31 milliseconds. Look at this milliseconds. 1000 milliseconds equal to 1 second. 1000 milliseconds equal to 1 second. It means 31 milliseconds means how quick it is. It's a light speed. 31 milliseconds means it's a light speed. It means you have a very good internet connection. If your ping response is below 50 ms, it's a very good internet connection. If the ping response is more than 100 ms, maybe the server is located in different continent, like it is in US or somewhere else. Okay, you guys understanding, right? So the latency will tell you what kind, how the connectivity between source and destination. Okay, if you play a PUBG game, right, you have a good latency, 20 ms, 30 ms, 40 ms, then only you can play very well. Otherwise the game will lag, right? So the enemy will kill you. Yes or no? Anyone PUBG guys here? Does anyone play online games like PUBG or anything?
Yes,
Right, so yeah.
sir.
So online games means it's a real time, so it should sync with the server. So yeah, you should have a good connection with the server. Also, you guys are using this ping keyword for chatting purpose, right? So ping me when you're available. So you guys are using this networking command as a charting purpose, right? So the ping is a real networking command. This is what it do. This is called front end. What it will do, it will check the layer reachability, and you will come to know round trip time, how much time it will take, and you will come to know what kind, how many packet losses we have. Easy, clear, everyone.
Sir, can you explain this packet, sir? What it is?
I will explain. You have to wait. Okay. I will explain
Okay,
what
sir.
packet it is. Okay. This is called front end. Okay. Front end, that's what you see. That's what I explained. Is it clear? Right?
Yes,
Now,
sir.
Yes, sir.
now, do you want to learn really what exactly will happen at the back end? Once you initiate a ping, what will happen at the back end? Are you ready to learn as an electronic device? Are you guys ready?
Sir.
Yes. Yes, sir.
So remember, here in Tungabhadra networks, you will not learn like a humans. You will learn like a machines. Is it proved or not till last class? We are learning everything in the form of zeros and ones, right? Like and operation and everything. What do you say, guys?
Yes, sir. Yes,
Right?
sir.
Yeah. Now, I also told you during an interview, if anyone is asking a question with the topology, don't blindly believe the topology. They try to confuse you. Always think like a device. Where exactly the data is going, from which device the data is going. Like the data is going from PC1, you need to think like a PC1 and answer it. Forget about topology. Don't look at the topology, think like a computer and answer it. That's where the practical exposure will come into the picture. Okay. So scenario based questions, dear experienced candidates, you might heard about scenario based questions, right, during interview. So if you
Yes,
want to,
sir.
yeah, if you want to answer those scenario based questions, right, you need to think like a electronic device. It means like పూనకం అంటారు కదా లోపల మనకు వస్తుందో అట్లా. You need to enter into the PC and think like a PC. Okay. Let's see how many will think like a PC now. Okay. Now let's start the actual process. Okay. So PC1 IP address is 192.168.1.1/24. And now PC2 IP address is 192.168.10.2/24. If I initiate a ping from PC1 to PC2, will it ping or not?
No, sir. No. No, sir.
May I know why?
It is different network.
Fantastic. How you identified it is in different network?
192.168.1 is one network.
Network ID.
192.168.10 is another. 10 is another network.
So how you identify another network means I'm
Under
explaining.
Network ID.
network address.
Network ID.
Network
Because
Network
ID.
ID.
Fantastic. Great. Use the keyword called network ID. So PC1 network ID and PC2 network ID is different. That's why it will not ping.
Different.
Okay. Now, if I remove 0, 1.2 now, it will ping, right? Both are same network, right?
Yes,
What do you
Yes.
sir.
say? Okay.
Yes, sir.
Fantastic. Now, look at this. Once you initiate a ping, okay? So ping is a command. At the back end, it uses a protocol called ICMP. What is ICMP? ICMP is a internet
Internet connection.
connection kadamma. Control messaging.
Internet Control Messaging Protocol.
Okay. ICMP. So ping uses ICMP protocol. Ping is a layer 3 command. It's a ICMP protocol. It's a layer 3 protocol. Okay. It uses a ICMP protocol. Okay. Look, remember that. Ping uses a ICMP. Very important. Now, on my computer, if I initiate a ping with some destination IP 1.2, what it will do? The PC1 will generate a packet. What packet it will generate? ICMP echo request. It is requesting. Suppose in this class we have a lot of people, right? So let me take an example. Anil. If I'm calling Anil, Anil will respond. So Anil is my destination, right? Same way. I'm calling to PC2 IP address. PC2 is my destination. So it is requesting it. So once you initiate a ping with destination, the PC1 will generate a ICMP echo request packet. Someone is asking, right? What is that packet? This is it. ICMP echo request packet. It will generate. Now, guys, tell me. Now you are sending a packet from PC1 to outside. So let's think about layer 2. So what are the two important fields in layer 2?
Source MAC address and destination
Source
MAC
MAC
address.
destination MAC.
Source
Okay.
MAC to destination MAC.
Okay. What are the two important fields in layer 3?
Source IP
Source IP
destination IP.
destination
Source
IP.
IP, destination IP.
Okay. Fantastic. So example PC1 MAC address is AA. Just an example. Okay. And PC2 MAC address is BB. Okay. Is it clear? Or else do one thing. Let's talk about real stuff. So what is the, so this is a Linux machine. You can just give show IP, you will come to know. So what is the MAC address? It is 68:00. Okay. 68:00 is PC1 MAC address. What is the PC2 MAC address? It's a big one, but I'm not going to write the big one. Only last two hexadecimals I'm writing. So 68:001, right? So 68:00 is a PC1 MAC address. 68:01 is a PC2 MAC address. Yes or no? Look at this, right? The real MAC address I am taking it. Guys, you understanding what I'm saying?
Yes,
Hello,
sir.
right? Now think like a electronic device. Now I'll come to know how many people really imagining themselves as a computer. Let's see. Now, guys, once you initiate a ping from PC1, it will generate ICMP request packet. Now let's enter the fields. Source MAC address. What is the source MAC address?
PC1.
68.0.
Okay, PC1 MAC
68
address.
dot double.
Yeah. What is the source IP?
PC1 IP.
What is that? Tell me.
68
192.168.1.1.
192.168.1.1.
Very good. Okay. Now what is the destination IP?
192.168.1.2.
Very good. What is the destination MAC?
68 colon
68
01.
colon
The
0.
PC1 don't know the destination MAC address, right, sir?
Yeah. So go on mute now. Whoever is saying 68:01, listen carefully. So you mean the computer is having a beautiful eyes and it is seeing the PC2 MAC address, right? It is having a eyes and checking the MAC address, right? PC2 MAC address. So the computer doesn't know where I am connecting to. There is a cable, it is connected to me, and it is connected to a switch or a router or a computer. PC1 doesn't know. It's a machine. Does the PC1 is having a eyes? No. You guys are having the eyes and you're checking that. How come the PC1 knows the PC2 MAC address? Think like a machine,
Switch destination.
right? Is it clear? So you know the destination IP address. That's why you initiated a ping, right? Ping destination IP. That's why you know the destination IP. So how come you know the destination MAC address? You don't know. PC1 doesn't know the destination MAC address. It means PC2 MAC address, whatever it is. It doesn't know. How come it knows? It doesn't know. So it will be question mark. Yes or no? Do you think the
Yes.
PC1 is having eyes like
Yeah.
a humans?
No, sir. No, sir.
No. So
No, sir.
always please think like a machine and answer it. So now you got an example, right? How you need to think like a machine. Now next time
Yes, sir.
onwards, please think like a machine. Now, so if you want to deliver any product, you should know the deliver address. Without having the deliver address, you cannot post anything. You cannot send the product. So you don't know the destination MAC address. So this ICMP echo request packet will go out. No, it cannot. So the until all fields are filled, right, the packet will not go out. So what will happen? This ICMP echo request packet will be in buffer. Buffer means like when you opening any video, it will be buffer, right? Because of slow internet connection. Same like that. The packet is in buffer. this packet, if you want to send out from PC1, it requires MAC address for this destination IP. So MAC address is question mark. Question mark means unknown. You don't know, right? Unknown. You need to find this unknown MAC address for this IP address, right? So yes or no? Do you need a MAC address or not? You need this MAC address. What is a MAC address? You
Yes,
don't
sir.
know. So now PC1, what it will use? You have a one more protocol here called address resolution protocol. So it is called ARP. Okay, address resolution protocol. So what is ARP? So you need a MAC address for the destination IP, right? The ARP will resolve it. So address resolution protocol, it will find the unknown MAC address for the respective IP address. So now PC1 generates ARP request packet. Okay, PC1 generates ARP request packet. Now in ARP request packet, you have a fields. Tell me, what are the layer 2 fields we have? Source MAC address, destination MAC address, right? Right? Here, when you're talking about ARP, you should not say source. You should say sender MAC address. Here, source as a sender, destination as a target. Okay. Now, tell me what is the sender MAC address?
68
Column.
Tell me 68 colon
double
01
zero.
00. Okay. This is called what? Sender MAC address. Now, what is the sender IP address?
1.1. 182.1.
192.168.1.
Fantastic. Now, what is the target IP address?
1.2.
F
192.168.1.2.
1.2. Guys, listen carefully. So, when you try to ping a IP address, if the destination IP address is in same network, it will be the target IP will be the same. What if the destination IP is different network? That is case study 2. So this is called case study 1 when both PCs are in same network. Okay. So what if both the computers are in different network? That I will explain later. So the target IP is 1.2. Now what is the target MAC address? You don't know, right? You need to ask. So in ARP, it will be broadcast. Broadcast means all F's, right? So if delivery boy don't know the address, what he will do? He will ask each and everyone, hey, do you know this customer address? Same way, the ARP request packet, the target MAC address will be broadcast. Is it clear, everyone?
Yes.
Yes, sir.
Yes, sir.
Right? So switch will only understands what?
MAC
Switch
address.
MAC address. So that's why it is maintaining a MAC address table. How many
Table.
interfaces we have in switch? One is E0, one is E1,
Even.
right? Two interfaces. Guys, now see the step-by-step process. Once you initiated a ping for the first time, it will generate a ICMP echo request packet. While filling all the fields, it doesn't know the destination MAC address. That's why PC1 generates a ARP request packet to find the MAC address. Now all the fields are entered here. Now this packet, ARP request packet, is leaving and it is going to switch. Now switch is a delivery boy. Switch received this entire frame on switch 1 E0 interface. Now switch is a delivery boy. What exactly delivery boys can check in your real life? Does they will check a source address or destination address?
Destination address.
Now,
Destination.
now,
Destination.
yeah, switch will only understands what?
Mac address.
MAC
Now,
address.
now here, which field exactly the switch will check?
Target Mac.
Fantastic. Target MAC. Switch will only understand MAC addresses, and switch received this ARP request packet, it will check the target MAC address. What is a target MAC address? It's a broadcast. Broadcast means it will send to all the ports except this receiving the port, right? So Only
Yes.
only E1 is connected, so this ARP request packet will exit through E1 interface. But before exiting through E1 interface, switch is a intelligent device, right? It will learn the sender MAC address. That's what, right? If delivery boy first time don't know the customer address, second time he will remember, right, in his mind. Yes or no? First time if you don't know the any address, you can find it by asking someone. Next time you will remember easily, right? Same way, switch. First time, first time if it receives any packet, right, it will stores the sender MAC address. Now this entire ARP request packet is hitted on what? E0 interface. Now E0 interface, it will learn the sender MAC address. What is the sender MAC address here? 68 colon
68 colon.
00. Okay. Now it learns the sender MAC address and send this packet to PC2. Now PC2 receives this ARP request packet. Computer is which layer device? Layer 2 or layer 3? Hello? Layer 3. Very good. So now you tell me, he is also a delivery boy. What exactly the computer will check in these 4 fields? No. I'm asking
IP.
IP.
what IP? What IP address it will check?
Destination.
Target
Sender.
IP.
Targeted IP.
Yeah, target IP. So, yeah, very good. So PC2 received this ARP request packet and it will check a target IP. Target IP is 192.168.1.2. Array,
Hmm.
this 1.2 is my IP address. Okay,
Hmm.
this target IP address is my IP address. It means you are asking a MAC address of me, right? Okay, let me generate a replay packet. So what it will do? This PC2 will generate ARP replay packet. Okay, what it will generate? It will generate a ARP replay packet. ARP request packet is this ARP replay packet. Now, when you generate a ARP replay packet, tell me the fields now. What is the sender MAC address here? 68 colon 01. What is the sender
1.
IP? 1 dot.
1.2.
What is the target MAC address now?
60.
Yeah, 68 colon
0,
00.
0, 0.
The PC1 MAC address, right? Look at this. Request came
Hmm.
from here only, right? So it will be
Hmm.
target MAC will be PC1 MAC address. Now target IP will be PC1 IP address
1.1.
1.1. Now it is generate a ARP replay packet and now it will send to switch
Send
1.
to switch.
But before it will send to switch 1, these computers also intelligent devices. These will maintain a ARP table. So computers maintains a ARP table. Now in ARP table you will have interfaces, okay, interface and IP address. For this IP address, what is the MAC address? So now here E0 interface and what is the IP address it is getting? 192.168.1.1. Look at the ARP request packet. So 1.1 IP address. What is the MAC address of 1.1? It will be 68
68 colon
colon 00. Clear? Yeah. So it learns the ARP table. It will create a ARP table. Who will create a ARP table? Layer 3 devices, computers. So if you want to check the ARP table in your Windows machine, give a command ARP-A. That's it. Look at this. This is my interface and you will see IP addresses and MAC addresses. Yes or no? Hello, everyone. Right?
Yes, sir.
So you can see I
Yes,
have
sir.
a lot of interfaces. Now you can see here. This is IP address and MAC addresses. Okay. See interfaces, IP address and MAC addresses. Okay. Yeah. So who will populate ARP table? Computers, layer 3 devices. So layer 3 devices create, populate means create a ARP table. It will store that information. Okay. Now once it is done, PC2 generates a ARP replay packet. It will go to switch 1. Now switch 1 received this ARP replay packet. Tell me what exactly switch 1 will check.
Target MAC address.
Very good. What is the target MAC address?
68.0.
Yeah, 68 colon 00. Do you have 68 colon 00 in my MAC address table?
Yes, sir.
Yes.
On which
Yes.
interface it learn?
E0.
E0, right? So
E0.
the ARP replay packet is going through E0. So it is called what? Unicast. Yes or no? 1 to 1. It will check the target MAC address 68:00 and it is there in my MAC address table through E0 interface. So it is exiting through E0 interface. This is called what? Unicast. Clear?
Unicast.
So now before sending this ARP replay packet through E0 interface, switch 1
Okay,
learns
this is
the
called unicast.
switch 1 learns the what? Sender MAC address. What is the sender MAC address here? 68 colon 01. So it is hitting on E1 interface, right? Yeah. So now see, based on after learning a MAC addresses, the switch will do unicast. Look at this. Based on the MAC address table, target MAC address is 68:00. It is learned on E0 interface. So the packet is exit through E0 interface. Now PC1 receives this ARP replay packet, checks the target IP address 1.1. Hey, 1.1 is my IP address. So immediately it will populate what? ARP table. Immediately it will populate the ARP table. What it will learn? It will learn a IP address. What is a 1.2 IP address MAC address? 68:01. Okay. Finally, you learn a MAC address of 1.2. Is it clear now? Everyone, is it clear? How
Yes.
the computers learns the MAC address? With the help of address resolution
R.
protocol, right? So now you learn the MAC address. Now whatever the ICMP echo request packet in the buffer, right? That will come into the picture. Now remove the question mark and fill the MAC address. What is the MAC address here? You have in a
68:01.
very good
101.
68:01.
0.
Now this ICMP echo request packet will go to the switch. Switch will check what? Tell me.
Destination
Which
IP
will
address.
Destination
the
MAC.
MAC address.
Destination MAC address. What is the
MAC
destination
address.
MAC address here?
68:01.
68 colon 01.
6801.
Yeah. Do we have this destination MAC address in our MAC address table?
Yes.
On
Yes.
which interface?
E1.
So
Related to the
the packet exit through E1. So it is unicast. Now PC2 received
Unique.
this. PC2 received this. What exactly PC2 will check?
PC2 will check the IP address.
Yeah. Destination not
IP
MAC
address.
address. Destination IP address, brother.
IP address.
So what is the destination
Destination
IP
IP
address?
address.
Yeah. What is the destination IP address here? 1.2.
190.
It means,
1.2.
yeah. So now it will give you a reply. Hey, 1.2 is me only. So immediately what it will generate? It will generate a ICMP echo reply.
reply.
Echo reply packet. Request and reply packet. Now this is ICMP echo reply. And now source MAC address is 68:01. Destination MAC address is 68:00. Source IP address is 1.2. Destination IP address is 1.1. Now the
1.1.
packet will go to switch 1. Switch 1 will check the destination MAC address of 68:00 and it is there in my MAC address table. On which interface it learns? E0. So
E0.
the packet will
And it
exit
will
through E0. Now PC1 receives ICMP echo reply packet. It means you have sent a ICMP echo request packet, you have received a packet. One packet you have sent, one packet you received. It means the ping is completed successfully. So you just sent a one packet. Look at this in real world. So here, if you initiate a ping with any IP address, so how much time in real world it is taking? It is taking 30
30 seconds.
seconds, 30 milliseconds. 30 milliseconds means 1000 milliseconds equal to 1 second. 30 milliseconds means very quick. But you learn this concept for 30 minutes, right? You learn this concept for 30 minutes, but it's worth. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Right? So yeah, this is how the packet level stuff. Now, whatever we discussed, can I show you practically with the packet capture? Are you ready, guys?
Yes,
Yes.
sir.
Yes, sir.
Okay.
Yes.
Look at this. So now I'm on PC1. So how to assign the IP address on PC1? It's a VPCS virtual machines. So simple IP 192.168.1.1 slash 24. That's it. Now another thing. So IP 192.168.1.2/24. That's it. Okay. See, the IP address is configured successfully. Now I am initiating a ping from PC1. Before initiating a ping, please do a packet capture. Right click on it, do a start capture so that it will show you the live packet capture. Okay. Now look at this. I am initiating a ping 192.168.1.2. See, are you able to see packets here? See, it's going on, right? Yes or no?
Yes, sir.
So what is
Yes, sir.
this?
Yes, sir.
PC1 is sending a packet, ICMP echo request packet to PC2. PC2 is replying it. So let's do a research. Once I initiated a ping, first of all, is it directly sending ICMP packet? No. First, it is generating a ARP because the ICMP packet was in buffer. Is it clear? ICMP packet was in buffer, right? First, it learns the
Yes, sir.
ARP. After learning the ARP, then only the packet will send out. ICMP packet will send out. So once you initiate a ping, what is happening here? First, it is learning a ARP. Look at this. So the computer one is generating a ARP request packet. Look at this. Here is a ARP request packet. Look at the layer 2 fields. Source MAC address 68:00. Is it matched, guys?
Yes, sir.
Here,
Yes.
here. Look at this. Not source, sender. Sender MAC address. Is it matched, guys? 68:00.
Yes, sir.
Yes,
Look at
sir.
every field. Whatever we discuss, everything is there. Look at the sender IP. Sender IP is
Yes,
1.1. Broadcast. Target IP is broadcast. Target IP address is 1.2. Whatever we
not
discussed, exactly every field is here. Yes or no?
Yes, sir.
Right? Now, once ARP request has sent, right? Next packet is, look at this, ARP reply. So now you see the ARP reply. So ARP reply, who is sending? Look at this. What is the sender MAC address? 68:01. What is the sender IP? 68, sorry, 1.2. What is the target MAC
wonder
address?
to
Yeah. What is the target MAC address? 68:00. What is the target IP? 1.1. Look at this, the reply packet. Look at this, reply. See, compare these two packets, live packet capture, request and reply. All the fields are matched here or not,
Yes, sir.
Yes,
right?
sir.
yes, sir.
Now, once ARP is learned, right? Check here in here. Show ARP. See, oh sorry, here, show. So here you can see, yeah, generally it's a Linux machines. Anyhow, so it generated a ARP. After completion of ARP, what it is generating? It is generating ICMP echo request packet. Look at this. ICMP echo request packet. Look at this. So the source MAC address is 68:00. The destination MAC address is 68:01. Match it or not? Layer 2 fields.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So so far you have learned there are two important fields in layer 2, source MAC and destination MAC. Today you are going to learn one more packet. One more field is called type. So this type will tell you what is my upper layer. What is my upper layer? My upper layer is layer 3 header. So that's why it is showing IPv4. So the type in layer 2, the type field will tell you what is my upper layer. It is IPv4. Okay. If you check it in ARP, right? Look at this in Ethernet 2. What is my upper layer? It is a ARP layer. Is it clear, everyone? Hello.
Yes, sir.
Yes, sir.
So
Yes, sir.
today you learn one more field in layer 2. What is that? Type. Okay.
Right.
Type.
Now go to layer 3 fields. Look at this. Source IP address is 1.1, destination IP address is 1.2. Is it clear? Clear.
Yes,
Sir.
sir. Yes,
Now
sir.
Yes, sir. Clear.
today you are going to learn one more field called protocol number. What do you mean by protocol number? The electronic device cannot understand what is ICMP. It cannot understand alphabetical things. That's why internally they assign each and every protocol will have a number. For ICMP, what is the protocol number? It's 1.
One.
So you have lot of protocol numbers like TCP also. What is the TCP protocol number? Can anyone tell? It is 6. Okay. So what is the UDP protocol number? It is 17. I will show you in the next slides. Okay. Each and every protocol will have a number. Okay. Protocol number means you will see it in which header? Layer 3 header. So far in layer 3 header, how many fields you learn? Source IP address, destination IP address. Today you learn one more thing called protocol number. This protocol number will tell you what is this protocol. Number 1 means ICMP. Clear, everyone? Hello?
Yes,
Yes.
sir.
Yeah.
Yes, sir.
Now, this ICMP, we have a lot of codes. Experienced candidates for you. When you initiate a ping, you will have a destination host unreachable, no route to the host. Have you observed this kind of things? That is called
Yes, sir.
the error message, ICMP error message. There are a lot of ICMP error messages. So type 8 code 0 means it's a request packet. ICMP type 8 code 0 means it's a request packet. Okay. Now, once the request sent, you're getting a reply from 1.2. Look at this. You're getting a reply. So look at the reply packet now. So what is the Ethernet field? Source MAC address is 68:01. Destination MAC address is 6800. Is it matched or not here? Both are matched, right?
Sir.
Now, in IP headers, source IP address is 1.2, destination IP address is 1.1, right? Now, it's a replay packet. Type 0 code 0 means replay packet. Okay. So, this is how exactly it is. Whatever we discussed theoretically, I showed it to you practically. ICMP echo request, echo reply. So, for the first time when you initiate a ping, first, what it will do? It will learn the MAC address with the help of ARP. This is called normal ARP. Case study 1. Is it clear, everyone?
Yes, sir.
Everyone, right? ARP request packet, ARP replay packet. After that, ICMP echo request, and then ICMP echo reply. So, the wonderful thing here is you cannot learn directly what is R. You have to learn when R will come into the picture. You are learning something about technology. When this technology will be used, at what circumstances it will involve. You should know that. Now you should know, now you know, right? When the R will come into the picture, what is R, right? This is more practical, right? Yes or no? Hello?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Now, one of the biggest interview question is, lot of people are confusing experienced candidates and all. Now, look at the packet capture and tell me, ARP is a which layer protocol?
Layer 2.
Layer 2.
Everyone agree with him?
Layer 2. Yes,
Yes.
sir.
Layer 2.
ARP is a layer 2 protocol. Look at this. Do you see any IP header here? Do you see any
No.
IP
No.
header layer 3? No, right? It's
No,
a
sir.
purely layer 2 protocol. In internet, someone will tell you it's a layer 2.5 protocol. No, there is no such a 2.5, 2.75 protocol. No, it's a purely layer 2 protocol. But in interviewer, he will tell that it you will see the IP address in, right? So just tell them, yes, with the help of IP addresses, I'm finding the MAC address. What is the purpose of ARP? We are finding the MAC address. MAC address
Finding
is
the
a,
match.
yeah, MAC address is a layer 2. Okay. So ARP is a layer 2 protocol. Take a packet capture, show them. ARP is a purely layer 2 protocol. But whatever you're talking about IP address is, right, it is just a payload. Payload means it's just a data. It is just a information. With the help of this payload IP address, it is finding that. That doesn't mean it's a layer 3 protocol. My name is Megastar Chiranjeevi. Does that mean I'm a Chiranjeevi? No, right? So people fans maybe his father may be a Chiranjeevi fan. That's why his son name is also Chiranjeevi. That doesn't mean he's a Megastar Chiranjeevi, right? Just like that only. It is just having the IP addresses. It means it is a payload of IP address. That's it. Is it clear, everyone? ARP is a purely layer 2 protocol. Clear?
Yes, sir.
Okay.
Yes,
Now,
sir.
case study 2. Listen carefully. Case study 2. Now, when two computers is having case study 2, both the PCs are having different networks. Both the PCs are in different networks. So network means, tell me now, PC1, let's take a new PCs here. Here PC, and you'll take one more computer. Okay. Now guys, look at this. PC3, PC4. Now PC3 IP address is 192.168.1.1/24. Now here it is 192.168.20.1/24. Now tell me, if I initiate a ping from PC1, PC3 to PC4, it means 20.1. I am able to ping or not? So if I want to ping, what exactly I need to do? How these computers are connected? Tell me. If you want to enable a communication between two different networks, what you
The
need?
routers.
Yes,
We need to use
we
router.
need a router. So
Router.
take a router now. So switch cannot communicate. So what you need to take? You need to take a router. Now PCs are directly connected to a routers. Is it clear? So now these router interfaces will have each interface will have a MAC address. Consider it is a RR1 and consider it is a RR2. So switch will only understand MAC addresses. That's why it is having a MAC address table. Router will only understands IP addresses. So what table router will we have? Guess it, man.
IP address table.
Yes, IP address table. That IP address table we call as a
IP
routing table.
address table.
Yeah, that IP address. Yeah, that IP address
Routing
table
table.
we called as a routing table. Is it clear?
Yes, sir. Yes, sir.
Right? Yeah. Is it clear? So the packet flow through these routers, I will explain through routing technologies. Today I will just give you a basic. What basic? Listen. Once you initiate a ping, right? Now it will generate a ARP request to find a MAC address, right? Now what is the sender MAC here? Consider PC3 MAC address is AA now. Just consider that. PC4 MAC address is BB. Listen carefully and answer carefully. So PC3, when once you initiate a ping, right, to 20.1, okay. So the ARP request is generating for what? Look at this. Sender MAC address. What is the sender MAC address? AA.
J.
Yeah.
What is the sender IP?
20.1.
1.1.
1.1. What is the destination IP? 20.1.
20.1.
So are you sure? That's now it is. What is the target? Generally target MAC address is FFF, right? Yes or no?
Mm.
Yeah. But look at this. Here, here, the destination IP, it is generating a ARP request for this destination IP? No. ARP request will not generate for destination IP. Look at this. I'm giving an example. Now you are staying in a double bedroom flat. Okay. Just imagine. If you want to go one bedroom to another bedroom, will you go through hall or you will jump from the window and go to the another bedroom? How you will do?
Hall, sir.
Hall, right? Until unless we are a Spider-Man, we cannot do that kind of stunts, right? Generally. So we are a humans, we can go through hall. Suppose if you want to go a supermarket, how you will go? Your home will have a gate, right? Some gate. Even if you're staying in a flat, even if you're staying in a gated community, the entire gated community will have a entrance, gate entrance. That's why gated community, right? So the thing is, guys, if you want to go outside, you will go through gate. Similarly, if the device is talking internal IP address, it cannot go through gate. Now I want to communicate with another network. Another network means outside the network. So I need to go through gate. So PC1 gate is who? This RR1. Okay. Who is the gateway? So once you configure, see, look at this. If you want to if you want to connect a different network, your computer requires minimum IP address, subnet mask, and gateway. Very important, gateway. You must configure gateway. Okay, if you want to go to the different network, you must configure a gateway. Now tell me, what is a gateway you can configure here? You have to take in the same network. So 1.1 to 1.254 are the available IP addresses, right? What is the
Yes.
gateway you're going to configure? You can take a fancy number, 1.100. I can choose 1.100 as a gateway because it looks fancy. You can take anything. So the same IP address where I need to configure, I need to configure on router interface here. Is it clear? Hello,
Yes,
everyone?
sir.
This is the router interface IP address. Okay. So G1/0 1.100. Similarly, it is 20.1, right? Here I can configure what? 20.100
100.
as a gateway. You can take anything, no problem. You can take 20.2 to 20.254, anything. I am taking this. So this is as a gateway. Now you tell me, when you want to go outside, the ARP request will generate for this destination IP or gateway?
Gateway.
Gateway
Gateway.
1.100. So remember carefully, when you're trying to reach outside, you need to go through your gate, right? So the ARP request will generate for gateway, not to the destination IP. So MAC addresses will learn on gateway. Clear? Make sense? First it will go to the router. Router can do routing towards destination. Clear? Hello?
Yes,
So
sir.
this is called what? ARP in a different networks. Okay. When your destination is in different networks, the ARP will generate for gateway. In case in your computer the gateway is not configured, the ARP request will not generate. If the ARP will not generate, the packet will not go. Okay. Your computer should configure a gateway. In case if you are not configuring a gateway in your computer, the packet will lost on your computer itself. Okay. You must configure a gateway here, and the IP address also, router IP address also should be reachable. Clear? So yeah, so this is called what in real world? It is called proxy ARP. What do you mean by proxy? Proxy means same thing. In your childhood, when you are in your classes or college days, right? If the lecturer is calling attendance, you may help your friend, right? Instead of your friend answer, maybe your friend is outside, maybe he's absent, but you are saying present for your friend, right? Behalf of him, you are saying attendance, right? Yes or no? Have you done that kind of thing, guys, in your
Yes,
childhood?
sir.
Right? That is called proxy. So nowadays everyone knows what is proxy. So you may see movies, right? In interview, during interview, you're not going to answer, someone going to answer for you. Yes or no? That is called what? Proxy. Same here. We supposed we are pinging 20.1, but we are learning a MAC address for gateway, not for 20.1. Yes or no? Right? We are trying to reach 20.1. We are not learning 20.1 MAC address. We are learning what? The gateway MAC address. This is called what? Proxy ARP. Is it clear? Experienced candidates and freshers and everyone.
Gateway MAC address or IP address?
Gateway MAC address ma. Why we need IP address? We know the IP address, right? So ARP is for what? To find the MAC address, right?
MAC
MAC
address.
Yeah.
address.
So the thing is, you are trying to reach 20.1, but you're not learning the 20.1 MAC address. You're learning the gateway MAC address.
100.
Yeah, 1.100 MAC address. So it's a proxy, right? You're supposed to learn 20.1, but you're learning gateway MAC address. So it is called what? Proxy ARP. Is it clear? Is it clear?
Yes,
Hello?
sir.
Yes, sir.
Okay. This is called normal ARP. This is called proxy ARP. Okay. So two kind of ARPs, it's clear. The packet flow, I will teach you when I start routing technologies. You will understand that, not right now. After hardware training, I will teach you. Okay. So this is called normal ARP. This is called proxy ARP. One more ARP I want to show you. What is that? Look at this. So first of all, when you try to assign a IP address to your computer, okay, IP 192.168.1.1/24, what it is saying? It is checking a duplicity. It means you're trying to assign a IP addresses to your computer. It is checking, hey, is anyone using this IP address in our network? If anyone is using, it is a conflicted. Okay, guys, you understand what I'm saying? It will check.
Yes.
It will check a duplicity in your network. How exactly it will check? How exactly it will check? By using gracious
Subnet.
ARP. See here, gracious ARP. What do you mean by gracious ARP? It will check the duplicity, duplicate IP addresses in your network. Suppose my name is Ramesh. In class, if anyone name is Ramesh, what I need to say? Tell me. Logic.
Initial will be zero.
So my name is Ramesh. I want to know is anyone name is Ramesh also. What I need to call?
With your subject.
Sorry, man. My name is Ramesh. I want to know,
Surname, call with surname.
man. Why
Surname.
surnames? Why surnames? Just name Ramesh, right? I will say, hey Ramesh. Now the
It will
Ramesh
be
will
generate the
respond.
duplicate.
Yeah, the Ramesh will respond. That's how I understand. Okay, someone name is also Ramesh. Yes or no? Right? Simple, I will call Ramesh. Why surname, man? Simple. If anyone name is Ramesh here, I don't know. So if I want to know, I'll call them. Hey, hi Ramesh. So if Ramesh is
Auto
available,
reply.
he will reply. Simple. Okay. Same here. It means source and destination is same. Same here. In ARP request packet, gracious ARP request packet, the sender IP, target IP will be same. Sender IP, target IP will be same. The packet will go to here. And in case if this IP, target IP also some PC2 is already using it, it will generate a error. Hey, this IP is already being used. Look at this now. I'm trying to assign 1.2. What it is saying, hey, 1.2 is being used by this MAC address. Look at the packet capture here. Look at this. So here sender MAC address, sender IP, target IP will be same, and the target MAC address like PC2 MAC address, it is telling that clearly. Duplicate IP address detected for this PC0 because it is also used by PC1 6801 PC2. 6801 is PC2 only, right? Yes or no? Understand, brother? Right? This is how it is telling that you cannot use 1.2, someone is being used. So how you identify this duplicity? By generating gracious ARP. Is it clear?
Yes, sir.
Everyone, is it clear? Okay. Gracious ARP. Gracious ARP, what it will do? It will identify. Tell me, it will identify duplicate
Duplicates in the
address
Address.
in your network.
Net.
Okay. Yeah. So how many ARPs you learn now? Normal ARP, proxy ARP,
Proxy.
gracious ARP. So now one more legacy ARP is there that is called reverse ARP. Reverse ARP is normal ARP reverse. Normal ARP, what it will do? It will find the MAC address with the respective IP address. Reverse ARP, it will find the IP address with the help of
With the
MAC
help of
address.
MAC address.
That's it.
Fine.
Simple. Wow, fantastic. You guys are on the same page now. Understand? Total how many ARPs you learn now?
Four.
Four.
Normal ARP,
Four.
proxy ARP,
Grace.
gracious ARP, and
Bar.
reverse ARP. At the same
reverse.
Reverse.
time, you learn how ping is also working. Right? Clear? How exactly ping works, what it generates. So yeah, this is the concept, guys. Okay. Now you have already set up the lab, right? In your laptop. Start doing practice. This one. Okay. This switch, whatever you see on the GNS3, it's a unmanageable switch. If you double click on this switch, it cannot work. It is just a plug and play switch. Okay. Yeah. So that's all for today. Thank you so much. Any questions? Anyone having any questions? How was the class?
Good, sir.
Very nice.
Do
Sir,
you feel bored? Yeah. Tell me.
Very understandable, sir.
Fantastic. So yeah, someone is asking something. Tell me.
is there any more packets, sir? Only two.
Man, we are learning more than enough. Okay. Yeah. Only four. Okay.
Sir, in layer 2 header,
Mm-hmm.
uh, type we have discussed, no, sir.
Yeah, ma. Yeah.
Upper layer you have told. Can
Yes,
you
yes.
please explain that once again? What
It
is
it
upper layer?
upper layer means what is the next layer? Next layer is whether it is a IP address, whether it is a ARP, it will tell you. Okay. If you
Okay.
see here, right? If you see the packet capture, it is just telling type. It is next is ARP. After Ethernet layer, you will see ARP. It is just telling you the next layer. Okay.
Okay. Okay.
In case if it is IP address, it will tell you IPv4. Okay.
Okay.
Yeah, that's how it is. Okay. Yeah. So yeah, fantastic. So case study one clearly. So prepare your own notes as well. And this is case study two. The packet flow between the routers you will learn through routing technologies. Okay. Yeah. So the tomorrow will be the another very good class. The class is I told you right when you type www dot any website on your browser, what will happen at the backend? So now you got a curious, right? What will happen at the backend? That is the power of packet level. So if you learn like this, what will happen at the back end? You will be the professional network engineer. You can crack any interview in any product based company. In if you give a interview in Amazon, the first question they will ask you, if I type amazon.com on my browser, what will happen? Simple question. So within that simple question, they will cover ping, ARP, DNS, TCP, all basics they will cover it. Okay. So I have taken a interview for the candidates. Check it in the YouTube. How I took a interview for them. Now they are in very good position. Please check it in YouTube. Okay. Yeah. That's all for today. Thank you.